Hey folks, I'm back here. We got another lesson coming up here. Last unit of the unit 2, last topic, I should say. And let's get started. It's a quick one, so it's only a couple examples, and then give you some work time. Okay, it's actually a section that's not even in your book. It's actually in the next book. It's the algebra book that I haven't handed it out to you. It's actually available online if you wanted to. So your assignment's going to be out of your journal coming up. So it's extension 2.6 extension. It's writing linear equations again. But we are only writing linear equations of parallel and perpendicular lines. Okay. So if you remember back while we had parallel lines, slopes had the same. Perpendicular lines, we had opposite reciprocals. So we want to make sure we remember that as we go forward here with the lesson, that parallel lines have the same slope and perpendicular lines of opposite reciprocals. So our daily objective today is you can write linear equations of parallel and perpendicular lines. So I just got a note here to start out with. It says you can use the slope-intercept form or the point-slope form to write equations of parallel and perpendicular lines. So you got a choice there. You can either use the point-slope form or the slope-intercept form. Okay, so let's take a look at example 1. Like I said, there's only a couple examples here, and we'll send you off. Write an equation of a line that passes through point 6, -2, and is parallel to the line y is equal to 1/2 x plus 3. Okay, here's our key word. Our key word is parallel here. So when you think of the word parallel, you want to think of the same slope. Okay, so you got the same rate of change, same slope. So if the slope is parallel, the line is parallel, we have the same slope. So this is the line that we're referencing, okay? So the line that they're referencing is this, y is equal to 1/2 x plus 3. This is a nice tidy line. It's already in slope-intercept. And as you can see, it's got a slope here of 1/2. Okay, so I'm going to put that down, slope 1/2. Okay, so by looking at that, you see that it's 1/2. And so this is not the same line. So we're finding a line that's parallel to that, but we're using the slope information from this line. Okay, our slope is 1/2, and it so happens that it contains the point 6 dash -2. 6, -2. So this is a classic point slope situation. You've got a point and you've got a slope. So it says write an equation of a line. So we can either use the slope-intercept or the point-slope form. So since we have the point, we have the slope, let's go ahead and use our point-slope. Y minus y1. I'm going to change colors there. I've been using black. For this part. So the equation is y minus the y of 1 is equal to the slope times x minus the x of 1. Okay. All right. So looking at this, we've got the slope here, nice tidy slope at 1/2. So we could put that in there. 1/2. And then in this area here, we've got the y minus the y from the point, which is -2. And that's equal to the slope, we already put in there, 1/2, times the quantity x minus the x from the point, which is 6. Now, it doesn't say that to convert it to slope-intercept, so we can just do a little bit of simplifying here. Subtracting a negative is adding a positive, and we have ourselves an equation, 1/2 times x minus 6. And circle your answer. Okay, so what are we doing? We're writing lines still, and we're writing lines that are either parallel or perpendicular. The first example is parallel. So we're going to be given a line that it's parallel to. We extract from there the slope, and so it is parallel. We're going to use that same slope along with the point that we're given, and using point slope to find our equation. Okay, the last and final example for this little lesson is example 2. We have ourselves a little graph here. It says, write an equation of a line that passes through -3, 1 and is perpendicular to the line shown in the graph. Okay, so there's our keyword, perpendicular. So if you remember back when we had perpendicular lines, we were looking for opposite reciprocals. Opposite reciprocals. Okay, so just to review there, if you have two slopes and they're opposite reciprocals of each other, you'd have, let's say you had two, one was the slope of 2, an opposite reciprocal one would be -1/2. If you had 1/3 or -1/3, let's say, you would have a +3, the reciprocal, then you take the opposite of it. Another example would be if you had 7/4 for a slope, you would take the opposite, which would be a negative, and then the reciprocal would be 4/7. So it's just a little review on opposite reciprocal. Okay, so back to this equation. It is running through -3, 1, or actually it passes through -3, 1. So let's write that -3, 1 down. And it so happens it's going to be perpendicular to this line. So let's take a good look at this line here and see if we can determine the slope. All right, so I'm going to go down 1 spot, 2 blocks, 3 blocks, 4 blocks, and then it's -4/1. So that is equal to -4. Okay, so it's perpendicular to it. So if it's -4, we're talking about slope, the slope will be equal to a +1/4. Okay, so opposite of negative is positive, and the reciprocal of 4 is 1/4. Okay, so again, we have the slope, we have a point. Let's use our slope point to find the equation. So again, I'm going to use the equation y minus y1 is equal to the slope m times x minus x1. Okay, so as you're looking at this, you've got your x1 is your -3, your y1 is 1. So as you go finish off your problem here, you would take your y minus the y from the point, which is 1, is equal to 1/4 the slope times x minus the x1 from the point -3. Okay, then let's tidy it up with some simplifying. Y minus 1 is equal to 1/4 times x plus 3. So again, we were looking for a line that's perpendicular to this line, and that runs through the point -3, 1. So if you look at how this would work, -3 would have been over here, +1 here, and it appears that we have a slope of 1/4 up 1/4, 1, 2, 3, 4. And that is kind of how it goes, like so. So again, what's our I can't statement here? We're looking for writing equations. I can circle my answer here. We're writing equations of lines parallel, same slope, and perpendicular, opposite reciprocals of lines that are either shown like we had or given. So short lesson today. Thank you so much for listening, and we'll talk with you soon.